Okay, good afternoon. My name is Kevin Espinoza, and today I'm going to be presenting my astronomy project. And in the first slide, I'm going to be explaining the geocentric model. And this model, to me, doesn't really make any sense, but at the same time, I have to understand astronomers from back then. They had a different way of thinking. Just it kind of like reminded me of like flat earthers, how they believe that the earth is flat. And it's incorrect, but here we go. And basically, this model is created by Plutonymy. And basically, in this model, the sun, moon, and other known planets such as Mercury, Venus, Mars, and Jupiter all orbit around Earth. And Earth is not even, to me, that didn't really make sense because, Earth is just one of the, it's not even a big planet. I mean, it is, but not really. And yeah, basically, the Earth is at the center of the universe. And this was actually accepted for about 1,400 years until the heliocentric model came in. And this was created by the Greek astronomer named Nikolaos Copernicus. And basically, this one's actually the more accurate one. The sun is at the center, and the planets orbit around it. And in this model, it actually explains the brightness and retrograde motion. And in this model, everything moves westward in the motion of the planet with respect to all the stars. And explain geocentric model by epicycles. In the heliocentric model, it is explained by the difference between in the orbital speed between Earth and another planet. So pretty much as you can see in the picture, it shows you how Earth orbits around Earth. I mean, my bad. How Earth orbits around the solar system, and it makes more sense. And I'm going to be explaining Kepler's laws. So the first law is pretty much Earth is sometimes farther away from the sun as it is when it rotates around the sun. So in the first picture, you can see the example. And basically, planets travel in elliptical orbits around the sun, and the sun is only one focus from the point of ellipse. And in the second law, this basically means planets move faster when they are near the sun. A line from the planet to the sun sweeps out in equal areas and in equal times. And in the third law, planets closer to the sun move faster in their orbits around the sun. And this basically means that the planets move faster when they are near the sun, as you can see in the picture below. And right here, I'm going to be explaining Newton's universal law of gravitation. This pretty much means directly proportional to the product of their masses, inversely proportional to the square of the distance between them. Pretty much, it's any two bodies in the universe attract each other with a force that is, pretty much like gravity. Just how the moon is attracted to our planet. And right here, I'm going to be explaining rotation and revolution. Rotation is basically the spinning of a planet on its axis, as you can see in the photos. Revolution is the motion of the body that travels around another body in space and in full orbit. Usually, the way our planet orbits is not like straight; it orbits like at an angle. And this actually explains the reasons why we have seasons. We have seasons because Earth is tilted at a 23.5 degrees from a perpendicular orbit, as you can see right there in the model. And the length of the daylight varies because of the angle which the sun's energy strikes at a given location throughout the years. For example, in the equator, the sun's very hot because it's always shining in that part of the world. And for example, there's just periods in Alaska where the sun doesn't even shine at all, and it's like pitch black for like many days or like many months. And right here, we're going to be explaining the phases of the moon. There's a total of 8 phases. The first one is new moon, and this is also the first phase of the moon. You can't see the moon because it's between the Earth and the sun. That's the reason why it's all like darkened now and you can't see anything. And then the second model is a waxing crescent. Pretty much is a phase of the moon coming from after the new moon before the first quarter moon, and it's basically lit up on the crescent of the right. So pretty much like it's kind of like at an angle where you can't really see the complete moon, and you can only see like a little piece of it. And the first quarter moon is pretty much the moon. It appears as a half circle, as you can see in the model. And yeah, and waxing gibbous is pretty much it occurs right before the full moon. So like as you can see, it's like slowly the moon's kind of filling up, filling up, filling up. And yeah, and this is more than half when it is lit, when it's illuminated, increasing the right other side, as you can see right there. And then the full moon, it occurs when the moon's surface is facing Earth and reflects the full light. As